Okay, so now we're ready to move to our next example. Our next example is going to be 4-7, which is found on page 90. And as we look at that example, you're going to notice here is the mechanism that we're going to be looking at. This is actually a linkage for a water nozzle in an automatic car wash, okay? So we want to determine the limiting position of the nozzle that is here. So as we look here, there's a motor that is connected to the crank. So at the center here is going to be our frame. Our crank is going to go around 360 degrees, connected to a connecting rod. And then what it's going to do is it's going to take this nozzle right here and it's going to oscillate back and forth or up and down. And it's going to have a fixed center back over here. So right here, you're given kind of most all of the dimensions that you need. It is missing that dimension, if you would, from the horizontal for the crank, okay? I'm going to draw this one again at 45 degrees because it looks like it's about that. So if you want to use that same angle, go ahead. But then everything else here should get you to the point where you can create the kinematic diagram. If you want to peek at the kinematic diagram, what it looks like, down at the bottom of page 90, on the left-hand side, this is the kinematic diagram in the position that we see here, okay? So what I'm going to do is I'm going to go over to AutoCAD, draw my kinematic diagram in this position here. And then once I have that first position done, we'll talk about and figure out those limiting positions for the total throw. Okay, now that we have our diagram all set, we are going to do the mobility calculation. Okay, you don't have to put it as part of the practice problem, but remember, it's always a good check. We're going to have 1 as our degree of freedom, but I want to prove it because then it just lets me know that I have my links identified and I have my joints identified. So first of all, link number 1 is my frame. Link number 2 is going to be the crank. 3 is going to be the connecting rod, and 4 is going to be the nozzle. That's 4 links. So if I go underneath my camera here, okay, my mobility equation is going to be F is equal to 3 times N minus 1 minus 2 JP. 3 times the number of links is 4 minus 1 minus 2 times the primary joints. We go back, those are labeled A, B, C, and D. So there's 4 primary joints. So as we can see here, our F is going to be equal to 1. This is 9 minus 8 is equal to 1, which coincides with what we are exactly expecting because we have just the motor input. Okay, so that's done. Again, you don't have to put that in as part of this problem because it's not asking us for it, but it's a good check to be sure everything's covered. Now what we're going to do is we are going to move our nozzle into position for the highest point and the lowest point, rotating around point D. So C, its path that it's going to be restricted to is going to be a curve. And I'm going to go to my 0 layer and I'm going to put a circle center radius with the center at point D, which is the center here, okay? And then at point C, and that radius is 2 inches. That is the length of that link. So along that path is where C is restricted to, okay? So now to find its lowest point, that is when link number 2 and link number 3 are in line and extended all the way down. A really good illustration of this is down here in the illustration we see to the right, where we have the length, capital L2, plus the length, capital L3. So that's the length of link number 2 and the length of link number 3 added together to create the radius. And we're going to find where it intersects with the path that C is constricted to or restricted to. So if we go here at A, we are going to be putting in a circle center radius with the center here. And you're going to tell me, what is my radius going to be of this circle? .75. How did you get that, Nia? That sounds right. we're adding the crank and the next link, right? That connecting link, right? So link number 2, the crank, and link number 3, that connecting link. The crank is 0.75. That connecting link is 2 inches. So the radius, yes, is 2.75. So I'm going to enter in 2.75 here. And the intersection that's created is right there. That's going to be my lowest position for point C. So now what I'm going to do is I'm going to draw a line, and it's going to be the object 2, because this is going to be a new position. I'm going to draw a line from D to that intersection. And that intersection is going to be my new point C. So this is going to be C prime prime. So I'm going to copy C down here, or C prime, this is my first one. Whether it's C prime or C prime prime does not make a difference, okay? And so that's the new position for C, okay? And that's going to be in its lowest position. Now I want to show C in its highest position. And again, it's going to be somewhere along this radius. And if I go back underneath, you're going to notice that its highest point is up here. And that radius is going to be link number 3 minus link number 2. This is where they're going to overlap one another and be kind of on top of each other, okay? On that back side of point A. So if I go here, and I strike an arc. Now, maybe there's not too many arcs, we'll see. Center radius, and I'm going to draw, I'll do go back to 0 here. Circle center radius. And now I want this radius. What is the radius that I'm going to be putting here? This is going to be link number 3 length minus the length of link number 2. 1.25. So how did you get that? What are the numbers? 2, which is the length of link number 3, minus 0.75, the length of link number 2. So yes, 1.25, that is correct. Okay, so now that is going to intersect right here. So now I'm going to go back to, I need an extra layer here, so I'm going to add a layer. I'm going to go on link or object 2. I'm going to rename it this time, object 3, and I'm just going to change the color to cyan. Okay. And now I am going to change my layer to object 3, and I'm going to draw a line from D to that intersection. And that's my new C prime prime. Okay. I just wanted to show those 2 positions, and then we'll add the lines back in for the other. So I'm going to copy C here, and this is going to be my C prime prime. Okay. So now this is the extent of my nozzle. This is how far my nozzle is going to go. So I'll finish up in just a little bit, but if I want to see the extents of this, okay, I'm going to put my angle dimension in, because notice that this is constrained to rotating about a fixed center D. Okay, this is not a linear displacement, so it's not going to be a linear dimension. So I'm going to click on each one of these, and you're going to notice that I get 47 degrees, okay? 47 degrees. And that's exactly what they get in the book as well, okay? So that lets me know I'm good, but I'm not done with this diagram. All I did was the endpoint. So what I want you to do is finish up the diagram, connecting the appropriate lines where the C prime prime is. You're going to have a B prime and a B prime prime, okay? So I am going to do that in the background, and then you'll do it as well. Then you want to add back in any labels that you didn't put in to this point. Oops. You could, yeah, that's no problem. So, yeah, David, and I think Tyler, you suggested the same thing, right? Could I just draw it and then draw a line to it? I think that's a very appropriate, especially when we're so close in here, right? Oh, I love object snaps. So nice. Two. Yeah, something like that. It's fine. And remember, this is really just a layout, but you are handing it in for a grade. So make sure that I can get the gist of what you're doing. But it's definitely not dimensioning to the MC standard. But don't cross over. So like right here, I'm going to move my C. And shit down here a little bit. There we go. So I think that looks pretty good. Pretty good. And then just making sure that your answer to the question, which is 47 here, what is the angular displacement of that link number 4, that nozzle? That's the 47 degrees, making sure you have that on there. Okay. Once you have these in place, okay, now you're ready to add this to your module 2 practice problems as well. So this is going to be a screenshot of this diagram. So you're just going to add that screenshot back to the, I'm going to do an insert, page break, and then this is going to be my example 4.7, and then Control V. So that's going to be the kinematic diagram in the extreme positions with 47 showing that you need for example 4.7. Okay. And we'll do a quick, oh, it did save. Okay. All right. And then we have one more to do, which is going to be 4.11. But before we break for our break, are there any questions at all on example 4.7? Okay. Can you show how to use extend line on the CN again? It's tricky for me. Oh, sure. So on the cyan line here, what I'm understanding, Tim, that you're asking. So I am going to go to my object 3. I'm going to add the line in, okay? And I'm going to go from here to here. So from C prime prime to the center of A. Then I'm going to make sure that I have my radius for the radius of our crank. That's that 0.75. So I had it in there. I just had gotten rid of it. So that's here. And then what you're going to do, I'm going to move my pin. Then what you're going to do is you're just going to hit the extend, which is underneath the trim. And you're going to hit that line once. And then you go to the line again, twice, 3 times, and it looks like it might be another one. Come on. 4 times to get to that radius. And you click it with your left mouse button. And you got to maybe kind of follow it along like I did there. Was that helpful? Okay. Yeah. You're welcome. Alex. I just did a line. Just a line. Yep. So Alex was asking, how do you connect those? I just did a line. Yeah, on the notes layer. That's all. Any other questions? All right. If there aren't, what we'll do is we'll take a break, about a 15-minute break, and then we'll come back and do our last example. So I will stop the